Hello students. Now those who have already seen the video of Coulomb's law, over there I already said what is Coulomb's law. If we have two stationary point charges, then these 2 point charges, they are going to attract or repel each other with a force. They are going to attract or repel each other with a force, that means the same force. Okay, and suppose the distance of separation between them is r. Okay, and from Coulomb's law we get this formula. I am not going into details because we have already done this one. I have already shown that force will be 1 divided by 4 pi epsilon naught q1 q2 divided by r square. This is going to be the force. Remember, this is for vacuum. This is for vacuum, or you can consider air. More or less it will be the same. Okay, for vacuum or air, this is going to be the force 1 divided by 4 pi epsilon naught. Now q1 q2 divided by r square. Now the factor which is going to change if there is any other medium, any other insulating medium. Any other insulating medium is glass, wax, paper, oil, anything else. If there is any other material medium, then the force of attraction or repulsion is going to change between them. Okay, so it depends on this factor epsilon naught. Okay, epsilon naught, as I told you, epsilon naught. What is the meaning of epsilon naught? Epsilon naught is permittivity of free space. Free space means vacuum. Okay, it is the permittivity of free space or vacuum. Okay, what is the meaning of this word permittivity? As I already said in the previous video, permittivity means the medium that is present between the two charges, it is going to permit or allow certain electric fields. Okay, now how much electric field it is going to allow, it depends on the medium, okay, that is present between the two charges, and that particular constant is known as permittivity of free space. By this we can understand how much electric field the two charges, that means the electric fields that are coming out from the two charges, that is being allowed by that particular medium which is in between. Now today we are going to see that if there is any other medium, okay, if there is any other medium apart from vacuum or air, then what is going to be the formula? There is going to be a very slight change in the formula. We are not going to use this epsilon naught, we are going to use something else. Okay, now suppose if there is vacuum or air, then we are going to use this formula. If there is a medium, okay, for any other medium, the force of attraction is going to be F will be, let this force be F naught, okay, for vacuum or air, and for any other medium I am considering Fm. So this is going to be 1 divided by 4 pi epsilon. This is epsilon, okay, this is epsilon naught and this is epsilon. Q1 Q2 divided by r square. Okay, now epsilon means it is the permittivity of that particular medium. You have to understand, epsilon means it is the permittivity of that particular medium, how much that medium is permitting the electric field to pass. Epsilon naught is how much vacuum is allowing the electric field to pass, and epsilon means how much that particular medium, it can be any medium, that particular medium is allowing the electric field to pass. It is also known as, one thing we can say that epsilon is the permittivity of that medium, or we can say that epsilon is also known as the absolute permittivity. It is also known as the absolute permittivity. Okay, now let this equation be equation 1 and this equation be equation 2. Okay, you will see from these two we are going to get one very important constant. So if we divide this to equation F naught divided by Fm, okay, so how much we are going to get? So see, if we divide this to equation, we are going to get epsilon divided by epsilon naught. Okay, so F naught divided by Fm, we are going to get epsilon divided by epsilon naught. This particular thing has a name, and this is known as the dielectric constant. Remember, this is capital K. Okay, this is capital K, this is dielectric constant. This is known as dielectric constant of that particular medium. Now, those who have already studied Coulomb's law, over there you have seen that over here, while deducing Coulomb's law, here also we have used one K. Remember, that K and this K, they are not the same. That one we used, that was small k. Okay, that was small k, and that was a dimensional constant. It had a dimension. That particular k's value is 1 by 4 by epsilon naught. We have seen that that has a dimension, that is a unit. Okay, but this particular k, this is capital K, this is dielectric constant. This is different from that k. This particular k is known as, this is a dimensionless constant. Okay, this is known as dielectric constant. This is a dimensionless, because you can see this particular k, how we are getting this one, f naught divided by fm. Okay, f naught divided by fm. So force obviously they are going to be cancelled. Epsilon divided by epsilon naught, both have the same unit, so they are going to be cancelled. So this particular is dimensionless constant. It does not have any dimension, any unit, nothing. Okay, now f naught divided by fm, or we can say epsilon divided by epsilon naught. Okay, that is k. Now how do we define k? We can define k in two ways. In two ways this dimensionless constant, dielectric constant can be defined. We can define it in this way, that dielectric constant, it is the ratio between the force of attraction or repulsion between two charges when they are kept in vacuum, okay, or air, and or to the force of attraction or repulsion when they are kept in any other medium. Okay, so dielectric constant, it is a ratio of the force of attraction or repulsion between two charges when they are kept in vacuum or air, that is f naught, to the force of attraction or repulsion between the same two charges when they are, it has to be the same two charges when they are kept in any other medium. Okay, or we can define k in this way also. You see, epsilon divided by epsilon naught, we can define k in this way, that k is the ratio between the absolute permittivity, that is the permittivity of that particular medium, to the permittivity of free space, that is epsilon naught. Okay, so it is a ratio between the absolute permittivity of that particular medium, that means to the permittivity of free space or vacuum or air. Okay, that is epsilon naught. So this is how k can be defined. Now from here we can see epsilon by epsilon naught is, we can write, this is k. Remember, this is capital K. Okay, this one also can be written as epsilon r. Okay. Epsilon r, what is epsilon r? Epsilon r is known as relative permittivity. Epsilon r is known as relative permittivity. Okay, and from here we can write epsilon will be equals to k into epsilon naught. Okay, epsilon will be equals to k into epsilon naught. This one also we can write. Okay, epsilon equals to k into epsilon naught. That means if we have two charges which are placed in any other medium, then the formula for force is going to be 1 divided by 4 by epsilon q1 q2 divided by r square. Okay, this is for any other medium. This is for any other medium, and if we know the dimension, and if we know the dielectric constant of that particular medium, if we happen to know the dielectric constant of that particular medium, then we can also write this formula in this way, 1 by 4 by epsilon. We can also write 1 by 4 by, instead of epsilon we can use k epsilon naught q1 q2 divided by r square. That means the medium between the two charges, they are still there, the medium is still present, but one thing we can do is we can either use epsilon, that is the permittivity of that particular medium, or we can write in terms of absolute part, that means the permittivity of free space. Okay, if we know this one, we can put the value, or if you don't know the value, we have to know the dielectric constant of that particular medium. Epsilon naught's value we already know, that is 8.85 into 10 to the power minus 12. Okay, that is the value of epsilon naught, 8.85 10 to the power minus 12. So the value of epsilon, if we don't know, okay, then we have to know the value of dielectric constant of that particular medium. Okay, now by seeing the dielectric constant of any particular medium, we can understand how much electric field that particular medium is going to allow. Okay, so we are going to use either this one or this one, either 1 by 4 by epsilon or 1 divided by 4 by k into epsilon naught. Epsilon naught's value we know, it is 8.85 10 to the power minus 12, and if we know the value of dielectric constant of that particular medium, then we can put this value. Okay, so that is all about dielectric constant. Now just one last thing, that is, remember, for any medium for any medium, remember, for any dielectric medium, for any medium other than vacuum, the value of K is greater than 1. Okay, for the value of K is always greater than 1. For all dielectric medium, the value of K is always greater than 1. Okay, so now see over here, if the value of K is greater than 1, and if some dielectric medium is placed between these 2 point charges, so we get the force to be in this way, 1 divided by 4 by K epsilon naught. K epsilon naught. So see, the denominator is increasing. That means the force is going to decrease. Okay, so for any dielectric medium, if there is any medium in between the 2 charges, okay, so the force between them is going to decrease from the force that was acting when there was vacuum or air between them, because you see the value of K, as I said, is always greater than 1, and if we put the value of K, any value, if we put over here, the denominator is going to increase, so the fraction is going to decrease over here. Okay, so the force is going to decrease if we have air between the 2 charges, whatever force was acting. Okay, now we have any other medium between the 2 charges, so now the force is going to decrease by a factor. How much factor? This factor K. Okay, so now the force is going to decrease by a factor K. So from here we can write Fn will be less than F naught. Fn is going to be less than F naught. Okay, so now the force is going to decrease between them by a factor K. Okay, so that was all about dielectric constant. Thank you for the video. If you like the video, please like and subscribe.